The extent to which you did well on question 8 is probably going to be determined largely by your ability to use the TI Inspire effectively. So in this scenario here, we've got the price of used car and we've got the distance that is travelled. So here we've got 7 cars and we're looking at the distance and price from the 1st of January 2010. We are told that the relationship between x, the distance, and y, the price, can be modelled by this regression equation. Now, we're asked, first of all, to find the correlation coefficient. So what you need to recognise is that the correlation coefficient can be found from the statistical analysis on the TI Inspire by looking for R. So R is the correlation coefficient, and by putting this information into TI Inspire in the spreadsheet and analysing it, we are going to end up with a value of R is equal to negative 0.994. And we are in part 2 then asked to write down the value of A and B. It says write down because, again, we're reading this straight from the calculator. So you're going to write down A equals negative 1.581 and B equals 33,480. And that is from the linear regression, and on your calculator it would appear as mx plus b. For part B then, we're told that on the 1st of January, Lena buys a car which has travelled 11,000 kilometres. We can see we haven't actually got 11 anywhere up here. We are asked then to find or estimate the price of Lena's car, giving you answers to the nearest $100. So we've got our equation here, which we can now fill in the parameters. So we know that y is going to equal A, which is negative 1.581 times x. Now we know in this instance x is 11,000 kilometers, so we're going to put in 11,000, and then we're going to add b, which we said is 33,480. If we do that, we end up with an answer of 16,089.5. We're asked to give it to the nearest $100, so that is actually going to be 16,100 to the nearest $100. Part C, we're told the price of a car decreases by 5% each year. Calculate the price of Lena's car after 6 years. So we've got our price, which we can take as 16,100, and we know that it's going to be depreciating by 5%, which is the same as multiplying by 0.95 for each year that it depreciates. So we know it's depreciating for 6 years, so it's going to be 0.95 to the power 6. And if we do that, we end up with an answer of 11,827.3. For part D then, Lena will sell her car when its price reaches $10,000. Find the year when Lena sells her car. Now here the easiest thing to do is probably solve this graphically. So in essence, we're interested where 10,000 is the same as 16,100 times 0.95 to the power n, and if we solve that graphically, we end up with n equals 9.28, but the question is find the year when Lena sells her car. So if it started in 2010, we're going to be looking at sometime during the year 2019.